Okay folks, so today's video is on purifying copper using electrolysis. So as always, I'm going to start with a quick quiz. So if you want to pause the video now and have a go at these questions. The questions are aimed at, this is all the knowledge you should hopefully know that you need before the lesson today, right? So before we can go on to study this, you should be able to answer these questions. If you can't, please go back and watch the last couple of videos about electrolysis. So pause it now, and then I'll go through the questions in 5, 4, 3, 2, 1. So what is an electrolyte? It's a solution, it's an ionic solution, an ionic compound that is either molten or aqueous. Aqueous is dissolved in water, right? Molten or aqueous. That means it's going to conduct electricity. What is electrolysis? Electrolysis is decomposition, which means breaking down. You could say breaking down, actually. It's decomposition of an electrolyte using DC electricity. Right, what are the products of electrolysis of sodium chloride solution? So it's important here. If I'd have said molten sodium chloride, remember what it's an electrolyte, it could be molten or aqueous. If I'd have said molten sodium chloride, well, it would have been sodium and chlorine because we'd have split that up. But it's in solution, which means that there are also some ions from the water in there. So you've got H plus in there and you've got OH minus in there. Again, this was the previous video about products of electrolysis. So sodium is more reactive than hydrogen, which means we are going to make H2. You're going to make hydrogen instead of sodium, and we're also going to make chlorine gas. What is oxidation? If you remember oil rig, oxidation is loss of electrons. So oxidation is loss of electrons. And where does oxidation happen? So if you remember, oxidation. So it happens at the anode. Oxidation happens at the anode. Right. So, purifying copper using electrolysis. What am I talking about here? One of the things to remember is when you do electrolysis, you are going to have your container. You're going to have your electrolyte, which is the liquid. You need your DC source of electricity with your wires. And then you have two electrodes. And we've talked about these electrodes. We've given them names before. And we always said that the positive one is called the anode. And the negative one is called the cathode. So electrolysis is the name of the whole process. The electrolyte is the liquid part, and these are the electrodes, the things that are dunked in the water, electrodes. Now, the electrodes are mostly made from graphite because it's quite unreactive, so it doesn't react with the liquid, but it conducts electricity. We have to have it conduct electricity, right? So it doesn't really interfere with the process at all. It's just a way of getting the electrons out of the solution or into the solution. That's why we make them out of graphite, so it's unreactive. In the example we're going to talk about today, we are not going to be using graphite as the electrodes. We are going to be, the basic setup for this is, we've got our container, we've got our liquid, and this liquid is copper sulfate solution. So copper sulfate solution, that means it contains ions of Cu2+. That's copper with a 2+ charge. It's also got sulfate ions in there, which are SO4 ions, and they've got a 2- charge. And it's in solution, so there's also going to be some hydrogens and some OH-, H plus and OH-. But all that we're really concerned with today, we're going to ignore all the others. We're mainly interested in this copper 2+ ion. So that's in there. We've got our source of electricity. And we've got our electrodes, but we're going to make these electrodes, instead of these electrodes being made of graphite, we actually want these electrodes to do something. We want them to react. We are making these electrodes out of copper. So like 2 actual copper bars sticking in, because we want to know how to purify the copper. Right, so I'm just going to focus in on one of these electrodes. So I'm going to just focus in on the anode for a second. I know this is only half of it, but just going to look at what is actually happening at the anode. So if you remember, the anode is the positive electrode. Right. So here's the anode, here's the wire coming off the top of it. This is made of copper. So I'm going to imagine we're zooming in on this. So instead of drawing it like a bar like that, I'm just going to draw it as in, we're going to look at the individual atoms, right? So this is like the smallest anode possible. It's obviously not actually this small in reality. And it's made of copper. Cu, 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 Cu. It's in our container. We've got, I'll draw it in blue. So we've got our electrolyte here, which is our liquid. Right, what happens at the anode? So remember, we talked about this in the quick quiz. So question 5, where does oxidation happen? Oxidation happens at the anode. And what is oxidation? Oxidation is loss of electrons. If this was graphite, this wouldn't happen with the electrode, it would happen to the things in the solution. But because it's copper, it's going to happen in this solution. So we are going to have oxidation happening. Oxidation is loss. So this is going to be losing electrons. What happens to Cu when it loses an electron? Loses electrons. So this Cu, I'm going to rub it out. It's going to have lost 2 electrons, which means it turns into Cu2+, because it's lost 2 electrons. So the half equation for that, so we've got copper, it's going to lose electrons. So it goes from Cu to Cu2+, and it's lost 2 electrons. That is what is happening here at the anode. And then if I do state symbols, this is part of the electrode, right? It's actually sat in there because it's solid. Copper doesn't dissolve in water. It's solid. But copper ions do dissolve in water, which makes that aqueous. So this is important. That fact that it's important means it dissolves. The copper goes from being part of the anode to it's gone into the solution, right? If we kept this going, this next one will do this too. So this copper atom, it gets oxidized, which means it loses 2 electrons, which means it turns into copper 2+. And then as soon as it turns into copper 2+, it's not solid anymore, it dissolves. So it just floats off and goes over here somewhere. So I'll draw it over here, Cu2+. So if you look, the anode is gradually getting made smaller and smaller and smaller because all the copper ions that are part of the anode are going to solution. So why is that important? So if I'm going to add some impurities here, right? This is not pure copper anymore. Cu, let's add some random other metals. So this is not pure copper, that is bad, okay? But then, if you imagine, gradually all of these bits of copper are going to get oxidized. They're going to turn into copper Cu2+. And so what's going to happen, when those have turned into Cu2+ and dissolved, so, you know, we're going to have more Cu2+, Cu2+, Cu2+. So the copper ions have gone from solid as part of the anode. They've been oxidized, they've turned to ions, so they're now dissolving into the solution. These little impurities, they sink to the bottom. There's nothing holding them into the anode anymore, so they sink to the bottom. Okay. Meanwhile, over at the cathode, so I'm just going to focus in on the cathode for a second. So go up there. So the cathode is the negative electrode. This one's also made of copper. So again, I'm going to zoom in and pretend that we're just talking about a nice small electrode here. So Cu, Cu, Cu. What happens at the cathode? Remember, cathode is reduction, easy to remember. Cuff cathode, cuff for reduction is reduction. If you remember back to oil rig, oxidation is loss, reduction is gain. So we need to be gaining electrons here. I'm going to draw my electrolyte. Okay. And remember, we were doing this with copper. We were doing this with copper sulfate solution. So it means we've got a load of copper ions dissolved in here. I've drawn this. I know I'm drawing them separately, but like they kind of fit together, right? So this is the one we've just done. So we've taken the copper from this anode. We've oxidized it, so it's lost electrons and it's turned into Cu2+. The Cu2+s are then attracted over here because this is the cathode and it's negative. And then when they get over here, Cu2+, they get reduced. So reduction is gain. So what happens? Cu2+, it gains 2 electrons. And what happens when it gains those electrons? It turns back into copper. And if we do the state symbols, if you remember, Cu2+ is aqueous because it's dissolved in the solution. But copper is solid because it's insoluble. And so this Cu2+, it gains 2 electrons, it turns into copper, which means it joins on there. And then like this one floats over here and does the same thing, turns into pure copper, Cu. And then that one's going to come over here and turn into Cu. And so will the others. And so the whole reason that we do this is the impure copper from the anode goes into the solution, which means all the impurities sink down here. And then the copper ions all go over here and the cathode gets bigger and bigger and bigger with pure copper. So at the end, you started off with a load of impure copper here and a tiny bit of pure copper. And what you've ended up with is all your impurities are at the bottom and totally pure copper over here. So to summarize that, so if you remember, it all comes down to oil rig. Oxidation is loss, reduction is gain. And oxidation happening at the anode, reduction happening at the cathode. So at the anode, we've got oxidation happening. So we're losing electrons. So we've got solid copper losing electrons and turning into aqueous copper in the solution, lost electrons. And at the cathode, we're taking that copper from the solution, sorry, that should be 2+, Cu2+, aqueous, and its reduction is gain. It's gaining electrons. So it's gaining those electrons and it's turning into solid copper. So those are our electrodes. Let's add in that. Stick it in a beaker. This is our copper sulfate solution. And then let's make it so this is our positive anode, this is our negative cathode. So this one is impure copper and this one is pure copper. And so this electrode gets smaller and smaller and smaller and smaller and smaller, and all the impurities end up at the bottom. And this one gets bigger and bigger and bigger and bigger and bigger because the copper goes from here, where it gets oxidized, goes into the solution, and then it goes from the solution onto the cathode because it's reduced. And so then you take this one away and you've got your pure copper. And that's how you can purify copper with electrolysis.